Hello everyone, in this video I'll be explaining the problem chargers. So it was asked in AtCoder beginner contest 471. Let's read out the problem. There are chargers with unlimited number of charging slots. At time 0 all slots are empty. Okay, the maximum capacity of a battery is V. When a battery is plugged into a slot, it is charged at a rate of 1 unit okay 1 unit until its charge level reaches the maximum capacity. That is, the charge level increases by 1 for every 1 unit of time that passes. So we need to process q queries in order. The q query is given in one of the following formats. Here it is guaranteed that t1 less than t2 less than t3 less than tq. Basically the time of the query is in increasing order, it's not in random order, which is correct, valid. So there are two queries we need to perform. So the query type 1 is, it will be in the form of 1 tq wq, which means at time tq we need to plug one battery with charge level wq into a slot, and when the query type is 2, it will be of the form 2 tq. So it's basically at time tq, unplug one battery with the highest charge level from its slots and output that battery's charge level. If there is no battery plugged into any slot, we need to display -1. Okay, so queries will range from 1 to 10 power 5, 3 into 10 power 5. The voltage range can be from 1 to 10 power 9. Query type for query type 1 and this tq, basically time is from 1 to 10 power 9, and the voltage for query is from 0 to V, which is correct. And for type 2 query is, the time is from, again, same this thing, 1 to 10 power 9. And that's it. All the the queries which are coming in order, they will have the timing as in increasing order. Okay, the input values are all integers. Got it. So let's move to the iPad and try to understand the problem statement. So it's a D problem, chargers. So what they've said is, we have slot, charging slot, and this slot is like infinite slots we have. Okay, infinite slots we have, and at time is equal to 0, all the slots are empty, which means we don't have any charging battery plugged in. And what they've said is we have to process q queries. Okay, and the query is will of the form two forms. It will be type 1 or type 2. What is type 1 type? So type 1 will be of the form 1 comma tq comma wq, which means at time tq we need to plug in battery whose volt, or you can say whose charge is wq. Okay, and this wq will be in the range from 0 to V, because V is the maximum volts a battery can have, basically maximum charge. Beyond this we cannot have. Okay, so type 1 you have understood. What about type 2? Type 2 will be of the form t comma tq, 2 comma tq, which means at time tq we need to unplug the battery with the highest charge. So the battery which has got a highest charge or volt, so that battery we need to unplug. Basically we are removing that. Okay, so this is a problem statement and looks very simple, and yeah, and all the integers whatever they can in the input all are integer, and they've said for each query whatever we have this tq, right? So it will be of the form t1 is less than t2 less than t3 less than up to so on, tq minus 1 you can say less than tq. So basically there are q queries, so all the timings are in increasing order. So the query is appearing at t2 whose time will be lesser than query appearing at t3. So it's like time t2 is less than time t3. So let's understand with one of the example, and you will definitely come to know like how we are solving this. So we have 7 batteries, maximum volt is 100, and the query 1, query 2, query 3, 4, 5, 6, 7 is of the form 1, 15, 60, 25, 80. So it is like 1, 25, 80. We have 2, 30. We have 1, 45, 0. We have 260, 270, and then 280. So initially all the slots are empty. Since all the slots are empty, so query 1 when you are processing, its type is 1, which means we have to plug in the battery. So here time 1 is 15, so at 15th time we can think of 15 minute or 15 second, unit doesn't matter, but we can say in general 15th unit of time the voltage is 60. The battery that we are plugging in, its voltage is 60. So it's like in the slot one battery is plugged in. Here we can say one battery plugged in. Okay, now at when we look into second query, it's like again the query type is on, we have to again plug in. So at time 2, which is query number 2, so time is 25 right now, and we are plugging a battery whose voltage is 80. Since the difference here is like 10, right? We had plugged the battery, one battery whose voltage was 60 at time 15, and now it's 25. So that battery's volt is going to be increased by 10, which is 70, the time difference, because every unit of time will make sure the battery's volt is increased by 1 unit, and the voltage 2, battery 2, its voltage is 80 initially. Now we are processing query number 3. Okay, when we are processing query number 3, it is of the type 2 and the time is 30. Type 2 means we have to unplug the battery. Which battery you are going to unplug? The battery which is having highest voltage. Okay, so if you consider now this, it is 70 and 80, you may say this we have to unplug, which is quite sure. Obviously we have to unplug this unit, but the voltage is not true right now. The voltage, if you see here, it's like the difference, the time difference is not 5. So since time difference is 5, so this W1's voltage is going to be increased by 5, W battery 2's voltage is going to increase by 5, and we have to unplug this now. When you are unplugging this, we have to display 85, which is here 85, right? Okay, So we have just one battery right now. Now we have a query 4 and we have query 4 and it's type 1, which means we'll have to insert the battery. So your time is here 45 right now. So the difference, what is there? It is 15 difference, right? So you are inserting one more battery whose charge is 0 initially, and right now the older battery whatever you had, its voltage was 75, and since difference is 15, so it should have been in the voltage of that has to be increased by 15, which is 90. And this battery, since it is inserted right now and it is charge of 0, so it will be 0 only. Now let's come to query 5, which means it's of type 2, which means we'll have to remove the battery which has got highest charge. So time is now 60. So the difference, if you see, the difference is 15. Okay, it's like 15 units of time has passed. When 15 units of time has passed, so what will be the voltage of the battery? So if you simply blindly add 15 to the 90, it is going to be 105. But if you consider the voltage max a battery can reach is 100, so it will be not 105, it will be 100. It's like fully charged, and the battery, this battery's charge is going to increase by 15. So 0 plus 15 is 15. So we are removing. So we'll remove this one. Okay, and we have to display 100. So here they have displayed 100, not 105. Okay, so because the battery at max can charge is just 100. It depends on V. So here V is 100. That's the reason. Okay, now let's take query 6. So again it is saying we have to remove the battery. So the time is now 70. If you see from previous, the difference is like 10. It was 60 initially, previously, and now it is 70. So 10 units of time has passed. So here this battery W4 will have a voltage of 25, because 15 was at t is equal to 60, and when t is equal to 70, 10 units has got increased, and we are unplugging this, and we'll have to display the charge, which is 25. So we have displayed. Good. And we don't have any battery in the slot. All slots are empty right now. And your time is 7. Query 7 you are processing. Okay. And time is 80. And it is asking us to unplug the battery from the slot. Since we don't have any battery in the slots, we have to display -1. So that's the reason they have displayed -1. Okay, now the problem statement you have understood fully. How do you solve this is the question, right? Because brute force approach, if we apply, that is not going to solve, because inputs are way larger. Okay. If you build array or something like that, and for each query you going to update the charge of the battery, it will take O of n, and since queries are up till q, so it will be q scale, so like 10 power time, so it will go TL. So we should think of in a way key every time when we are doing something, right, when we are inserting or when we are unplugging, so that should happen in a either O of 1 time or log of q time. Okay, it should happen in this way, then only our solution will be accepted. So the one data structure that I can think of is priority queue. Priority queue, which is also known as max heap, because max heap it is a tree data structure, so it will contain the elements. Basically in the max heap, what we will be storing? We will be storing the batteries which are plugged in, and the top element will give you the battery which has got maximum charge. Okay, So yeah, this data structure looks quite suitable for our problem. So we'll be using this. So how to use it now is the question. Um, Let me just copy this example one more time. We are in N was 7, maximum voltage was 100. We had 7 queries. 7. We have 1, 15, 60, 1, 25, 80, 2, 30, 1, 45, 0, 260, 270, 280. This is the question. So in the max heap, how do we store it is the question, right? So our problem always start with time is equal to 0. So what I'll do is I'll pick a query 1, okay, and it's a type 1, which means we are basically inserting the battery into the charging slot. So when you are doing that, it says now time is 15 and the initial charging of that battery is 60. Okay, so time is 15. What I do is I'll take the reference of time is equal to 0, which means this particular battery at time 0, what would have been its voltage. Okay, so what I'll do is I'll basically subtract 15 minus 0. What is it? This is time 15. We are referencing with the 0. So right now charge is this, but 15 units, yeah, since we are doing a 0, so we can skip this. We can say 15 units back, this would be the charge of the battery. So the W1 new, that comes out to be 45, and we are referencing with time 0. So all the batteries will be referencing with a time 0, and we'll be calculating its the voltage. Okay, so now we have got a battery, let's say at time 0, which was inserted with the initial charge of 45. So in our heap data structure, we'll be inserting this 45, and we have just one battery. Cool. Now we'll move to query 2. Now query 2 again says we need to insert at time t0 25, we need to insert a battery to whose voltage is 80. Okay, looks cool. So what shall we do? We have a time 25, we'll reference with time 0. So your WT is going to be 80 minus 25, which is 65, yes, 70, no, it will be 55. It will be 55. Okay, so yeah, we have got now. So this our node, and now your heap will look like something this way. Let me write down. Your heap will update. So your 55 will be at the top, and 45 will be at the its child. Okay, it's like battery 2, which is highest, and from the previous calculation also we did calculate it was highest. So let's query the third one, then we'll understand. So when we are calculating the third one, so your time is 30, and it is saying you have to unplug the battery with highest charge. Cool. So we'll go to the heap and we'll say what is the top element. It will say 55. So it's like we'll say the battery whose charge is 55, volt is 55, is the highest one. But it is not the true, because at time 3 the battery's voltage was 85. okay, but we have just 55. So what are we missing? So since we have referenced this time with time 0, so we will be basically adding this with time to 30. I mean this 30 to the voltage. So it will be 85. So which is correct, like from the previous calculation, which was 85. And we need to display this, and we'll be removing this element from the heap, and your heap now will look like just 45. So basically in the problem statement, main thing was we have to reference time to 0, then calculate it. So I think you have understanding now. Let's take query this one. Your time is 45 and your voltage is 0. Now, okay, so we have to reference this to time 0. So we'll be separating 45, it will be minus 45. You will be inserting minus 45 into your heap. Now you will move to the query, query 5. It is saying your time is 60 now, you have to unplug the highest charge battery. So I'll move to heap and say what is your top element, let us say 45. So I'll take volt as 45. But as you have seen, when query was 5, your answer was 100. It was not like 45. So what are we missing? This base time. So you have to reference with time 0, which means now we'll be adding 60. So when you're adding 60, it will be 105. But whatever voltage you will have to display minimum of V comma this particular V. Okay, this V is this calculated value. So minimum of V is 100 here. So yeah, it will be 100 comma 105. So minimum is 100. So 100 will be displayed, and you will be removing this. When you remove this, your heap will now look like minus 45. Good. Now we'll take query 6. Query 6 is time is 70. You have to unplug the battery having highest charge. So now you move to heap and say what is your top element. It will say minus 45. Good. Now referencing time, you have to take 0. So you will be adding 70. So this will give you 25, right? And we have to display this. So at query 6, our answer was 25. And now the last thing. Now since you are removing this, your heap is empty. Heap is empty. Now you will move to query 7 and it will say time is 80. You have to unplug the charger. But when you go to heap and say give me a battery having highest charge, it is going to say you we don't have any battery. So since heap is empty, you have to display -1. So this was it about the problem statement, not anything a lot, just the time referencing to 0 and using priority queue. So I think you guys have understood the problem statement. Let's move to coding part. In the coding part only I will be explaining you everything. So in the input we have Q and V. Q is basically number of queries, and let me call Q capital V. Let's take their values, and I'll initialize one priority queue. It will store the batteries having charges, particular volts. I'll be processing Q queries. Okay. So for every query we have a type 1 or 2. So first I'll take type. I'll check if type is 1. So which means we are inserting the battery into the charging slot. Else we are removing. So when we are inserting, so when you are inserting, it's of the form 1, TQ, V. So we'll be taking T and W. So you have taken time in this thing. Now whatever voltage was there, as I said, we have to make sure it is referenced to 0. So you'll do T, W is equal to W minus T. T is basically time, okay. This is present voltage. So at 0th voltage, what was the volt? So this is the perfect equation, and in the simplified form you can write T minus 0 to be T and remove this bracket, okay, and this can also be written as minus equals to this thing. Now simply add into, push into priority queue this W value. So this is type 1 operation is done. Now coming to type 2 operation, which means you are removing the battery with the highest charge. So you'll be taking T again now, okay. So in this case, what you'll say, first you'll say your volt is minus 1, and you'll check if priority queue is not empty. Then you are basically unplugging it. Else it's like you need to you don't have any battery to unplug, so you'll have to display -1. So that's the reason I've taken -1. And when you're displaying, you'll be displaying minimum of V comma this volt. Okay. So since your V is from 1 to 10 power 9, so in case you don't have any battery to unplug, definitely -1 will be displayed. And don't forget handle. So when you have a battery that is plugged in, okay, so how will you get volt? So your volt is gonna be priority q dot top element, and remove that battery. And since it was referenced to time 0, okay, so you'll have to add this particular time to your volt. That's it. Let's try to run it. It's running fine, but this will fail. I'll tell you why. Because here time is 10 power 9 and query is 10 power 5. Okay, so multiplying this will give you 10 power 14. So the here whatever we are adding in volts, right? So this can go up till I mean it can surpass the integer max limit. So this volt I will take as long. Similarly, this W we are subtracting, right? It can go up to long minimum, I mean in negative side. So I'll be taking long, and since we are pushing into priority queue, so this also I'll be taking it as long. Now let's try to run it. Okay, volt and this comparison fails now. So here, since volt is long and V is integer, so let's take this also as long. So it is passing. Let's try to submit this now. So yeah, it got accepted. So in this way, you could have easily solved this problem. And if you try to analyze the time complexity, the priority queue operation, I mean push operation will take log of n time, and top element will be O of 1, but pop operation again will be log of q times. So overall the time complexity is q log q. And space complexity, since we are using all q queries to insert into this priority queue at max. Let's say we are just inserting, we are not unplugging, so at max it will hold q number of batteries. So space complexity is linear. So yeah, thank you guys.